This is Apurv. In today's session, what we have is API management in cloud. Now, specific to cloud, is why especially in cloud. The reason is basically you can do API management in your local on-prem also. However, cloud is where we have seen the multi-cloud strategies and things going beyond your on-prem, and enterprises are getting challenged in maintaining their systems on-prem. So that's why in cloud. Otherwise, you can pretty much do it on-prem also. Okay. So here's agenda for today. What I want to talk about is why exactly you need the API management. We'll talk about the core components, building blocks of your API management. How do you secure your APIs? The common policies, uh, some deployment patterns, and hands-on Azure API. However, I just found out somehow the Azure APIM instances are not getting created for me. So I'll probably try to see on APG if I have time. So pretty much that's what I want to cover. It's a bit very seems to be too much, but let's see how much we can cover, and then we can go further in next sessions. So pause me, have a chat. Let's talk about anything that you want to understand more, or you want to talk on. Okay. So here we go. This is, you can see the entire online software development cycles are pretty much tied on the API management, APIs basically. And APIs are how the businesses today build, connect, and access our modern applications. And API management is the way the businesses can securely deliver these connected experiences, right? So we need a lot of things. The whole world is pretty much API driven now, and everywhere we need APIs. But before we jump into that, let's see how we reached here. Okay, so this is we'll talk about the evolution and how we get here. Okay, the journey started somewhere when the computing was actually started somewhere in 1960s when the mainframe was introduced. At that point of time, there was not a lot of requirement to do a talking between the machines or the people. It was very much niche areas. Then came the 80s when the mini computer was introduced. At that point of time, how would you use computers was using floppies and basically ROM, read-only memories. At that point of time also, there was not much of need to interact. Then came the time of 90s when the desktop computer was introduced, and we had started the journey of using the computers. However, still the time was about copying data from one machine to another, and you would pretty much use someone else's uh, software or code on your machine by copying and running it. The boom came when we got the internet somewhere in 2000, when we started to see the client server technologies. This was a time when things started to interact a bit. It used to be area where there used to be a client server communication. There would be a server and there would be clients. However, the clients would be mostly installable clients, where the clients would talk to the server on the HTTP and they would interact. Uh, then came the era and the time where things started to get into web, and that's where this started to pick a, a lot when we had browsers, browsers which can interact with your backend systems. They needed a high UI which can be developed into JSPs and PHPs and those sort of things, CGI times. When it started to interact, then we moved on and we had this mobile internet and mobile era where we now have new systems which started to talk a lot to the different systems, to different machines, to do different kind of things. Mostly, pretty much, however, I mean, to be only on using something like videos or some mail or those sort of things. And now is the era. I mean, some time back only, it's not the era right now, but it started now. We have our devices, mobile devices, our internet, like wearable machines, IoT devices, sensors, and all sort of things where we need interaction a lot. And these interactions are not possible if we keep on using the time of the client server technologies or other times. This is the era of being thinner, leaner microservices, and everyone talking to every other thing. Uh, we don't know what else. Okay. So this is where the APIs come into picture, and they allow interaction between different and any kind of machines. They can talk over APIs, whatever data someone is exposing, it can be fetched and be given back to anyone who is interested and who wants to do something with it. So that's how we reached here, and that is how this evolution came up. So I came back to again to why it is needed, and this is where it is. This is the era of moving from monoliths to microservices. I guess pretty much each of us in software domain knows that we are moving to the era of microservices, which are thinner, leaner, and do the kind of work that they are supposed to do. Right? Very agile, very lean. There is a very small set of people who work on a specific microservice. They deliver it and keep on iterating, improving it each day and each as soon as possible. I guess, right. This is the time we are into. So microservices is one of the concerns which is affecting a lot, and that is why the API management solutions comes in handy and is really required. Okay. The next we talk about is security. Security is one of the prime concerns when you want to create an API. Now, it is somewhat related to microservices because microservices are supposed to be leaner and thinner and shouldn't do what it is more than what it is supposed to do. So, how would you allow it to be leaner and thinner? Is to abstract out the concerns which are not necessary to be built into microservices. Security is one of the concerns where you can extract out the security from the microservices and it pull it out and employ it somewhere else. It can be anywhere. I mean, not needed necessarily API management. However, API management allows you to do it in a centralized place and in a seamless way. So that's where it allows you to secure your APIs in a seamless manner. The next point is about onboarding, right? I mean, because of this boom of the APIs, there is a requirement for getting people to use your APIs, and you want to be able to handle their access and revoking their access, right? And it's the same responsibility if we give it to microservices. Our microservices will start to become a bit monolith rather than being a microservice, right? So, and this concern also gets handled by a API management solution. The next we talk about is lifecycle management, as in versioning. When you have these APIs and you build a lot many of them, there is a need to version them. Uh, you're releasing 1.1 and somebody is using them in production. Now, you really cannot stop someone or break their functionality just because you are upgrading your systems, right? So how do you manage it? Maybe you release your own system. You can keep on improving your versions, and then allow other to use the new version or the latest version later down on time whenever they're ready. So they evolve and you will evolve at the same point of time. Next point is about discoverability. And discoverability is an area where you want your APIs to be seen, as in you are producing so many APIs, you have so many microservices, and you want to be able to understand what what is the contract. If I call API, what is the data I will get? What are the errors that will occur in that journey, and to be able to handle that. So discoverability is what is also provided by API management solutions, and this is via a developer portal and via swaggers, which is pretty common to be shown, and you can interact with the APIs and then finally implement that. Then another feature that is given by the API management is analyzing your APIs, how they're doing, what they're doing, what are the issues, errors, and how do you handle that, right? So API management solutions provide you analytics through which you can see what is happening with your APIs, how they're operating, what are the issues there. Okay, one more point is here, and which is kind of in fancy, however, is coming up soon. I mean, pretty much nowadays is about monetization. I wouldn't put it because the monetization support is not big. You will have to do something of your own to really monetize. Monetization is actually where you have probably your API developer or a business who is providing APIs so that your data can be accessed and utilized by someone else. Now you cannot keep on doing this for free. So how would you handle that? And that is a monetization. So you can understand who is using your APIs, and based on that, you can suggest, okay, you can use X amount of cost to my systems, and then based on that, I charge you this amount or X amount. However, this functionality is not really built into the systems at this point of time, but surely in future you will see these features getting built, and you'll find the supports for it. Okay, I take a pause for any questions or anything that you are interested. Okay, be good. Okay, so Let's talk about the core components of the API management system. Okay, we have what is called as an API manager or the control plane, and you will find it in all, I mean, every other API management systems that there is a control plane who handles the basics of your API management system. It gives you an interface where you can see your APIs, you can see your backends, you can do other things. So you will have pretty much have a control plane. Then you have next is a gateway. Okay, gateways are where the actual API management is built into. Okay, they provide you functionalities to do the things that you want to do on API management system. Gateways come in two types. One is an enterprise gateway. It's pretty much a term for APG. However, you will see that similar in APG, Azure, or IBM, or Moonsoft, or anywhere else. So there is a one full-blown gateway which provides you the functionalities of your API management system. And then there is a micro gateway, which is a leaner and thinner gateway, which provides some of the basic functionalities of your gateway, and it actually interacts with your control plane for most of its configuration. However, this is also one of the good use cases for your internal API management systems. We'll see some of the patterns that is required. The next component for a API gateway is analytics, and which is where you see a lot of data which gets collected. And you will see that when at this point of time, X amount of traffic was coming, how much was the response time, what is the backend systems are interacting with it, how much time they're taking. So analytics is pretty much for your business or your business to understand how your API management systems are doing and APIs are doing, and you can take decisions based on the analytics. The next thing is the component is your developer portal. So pretty much all the API management systems provide you with a developer portal to expose your APIs and to interact with them. Now there is one confusing understanding, or there is a confusion people have when they actually see or interact with the API management. So there, what you see is there is a API that gets deployed onto your actual microservice. That is your real API. However, there is a API which is for which gets deployed on an API management system. That is actually a proxy rather than being a real API. So some of the people have this misconception or a misunderstanding that I have an API in their API management solution also. However, that is not the case. The API that you deploy is really a proxy, and APG calls it pretty much proxy. However, in Azure terms, it's called as API, so it gets a bit confusing. So, wanted to have that not have people having that misconception. Okay. The next next core component is a set of policies. Almost all API management systems comes with a set of policies, which are authentication, caching, rate limiting, transformation policies, to allow really implement the proxy functionalities. Now, idea behind these policies are they should not be very logic. based, it should be pretty light and should have minimal set of expressions or configurable policies, basically, where to authenticate you can actually verify, okay, somebody is calling me, what are the secure whatever security mechanism I've implemented in my APIs, that is getting validated and that is getting verified. In case of rate limiting, you want to stop your APIs being called so many times so that you can stop your backend system being overwhelmed, and you can stop, say, hey, okay, you made my APIs 1,000 times. Now you can take a break for, say, 5 minutes, and then you can make a call again. So that kind of functionality is that you implement using your rate limiting policies. Transformation policies are pretty much for converting or being adapting your systems. Say you have a legacy API which is using SOAP based mechanisms, and it returns you a SOAP response. Now you can convert your SOAP response into your microservice, or you can pretty much implement this transformation in your proxy and send the response back. Okay, so these are a few transform. There you will find XML to JSON, JSON to XML kind of transformation policies through which you can convert your responses to what is required. Uh, so this is about policies, and these are pretty much the basics that you will find in all the API management systems. Sorry guys, I mean, if you have a question, it is not integrated, so I'll have to come here and see. Was there a question? You can pause me if required. Oh, okay. Okay. So sorry. So yeah, let's talk about security. And as I said earlier, security is the main concern which is solved by your API management solution. So these are a few basic policies through which you can handle the security of your APIs. And it's really the actual API that you're securing. So client ID, client secret is the basic one where pretty much every API that you will expose, you can use a client ID and client secret. So whenever there is a developer or a business who wants to use your API, you can put that requirement for using a client ID and a client secret to be provided when the API call is being made, so that you can verify that client ID was passed. Now, this client IDs are pretty much registration based. So when a developer gets onboarded, he will register on your platform. He will interact with your the developer portal, and he will register or um, ask for a client ID and signing up for an API. So that is a point where your API management platform comes into picture, and your administrator or a person who is handling this request will be notified and will be asked to allow this client or the developer to be onboarded, and he will go ahead and, okay, using the management portal, he can issue him a client ID and a secret. And with that, this client ID and client secret will be available, and the other person will start to interact with the actual API. So he can use the developer portal to see how it is calling the APIs, and how what is the request and the response coming back, and he will try to check the real interactions with your API. Uh, so that is a very basic one. In Pretty much here, you there are the terms, few terms, which is called as a product and an app, where a product is a clubbing of all of your APIs, and an app is where a app gets is a representation of your real app. It can be a web app, it can be anything. So that web app, if it is subscribing to say multiple APIs, say you are a banking concern, so you can have open your open banking APIs, you can give your insurance APIs, you can give your mortgage APIs and expose them. And your app, which might be using two of them, can subscribe to two products, say mortgage product and open banking product, and they can start using them. So that is some terms of products and app. We probably can see it in a demo when we can try to interact with them. Uh, so next policy that you can pretty much implement is a OAuth policy, and OAuth based validation of your APIs, where you actually want your APIs to be first issued a token or be verified before making a call or a next call. So there are different terms in OAuth, and you can have different type of implementation. There is OpenID Connect, which can be used. Uh, or there are different grant types. So maybe we can get into detail in some of the detailed OAuth based or security implementation session. However, OAuth is a scenario where you would first get authenticated, and then you will get a say a token, and the next set of API calls that you will make is the bearer tokens. So you will present your bearer token to your clients, so to your API management system. It will validate whether the request is valid, whether the token is valid or is not expired or something, and then it will allow you to make that call. So that is a very good pattern to you secure your APIs. The next setup or next level is actually where we use MTLS and HTTPS, missed HTTPS, however. So, because of the inherent nature of your client ID and client secret being pretty much open text, okay, these are randomized characters of say 32-bit or whatever type of uh, mechanism that has been implemented. They're pretty much open in your browser or your in HTTP calls. So a pattern that needs and should be implemented is HTTPS, and which will allow these client ID and secrets to be transferred in a secured manner rather than being used or being I mean decipherable when an interaction or a network call is being made. So you should implement HTTPS based implementation where the calls are being made on in a secure manner. And you can implement MATLS, which is mutual authentication of your client and the server. So in case you want your clients to be is a very secured implementation where you will actually issue or you will put the certificates of your client on your API management system. And whenever there is a call made, you will first validate whether the certificate is being passed when the call is being made to the APIs, and pretty much getting into a standard to use a very real secure mechanism to do a HTTP or HTTPS based implementations for APIs or network calls. So these are the few patterns that you implement security for your APIs, and you should be using, I guess, at least both of them, and if not all of them. Sorry, guys, I'll check. Uh, Maybe somebody. I'm getting some pings, so I'm thinking that somebody is uh, saying something. Okay.
Apu, a quick question.
Yeah.
Could you run through, please, if you don't mind, an example, a scenario for OAuth where it gets used?
Where it gets used.
Yeah.
Okay. So say you want client ID. See, client ID and client secrets are very basic mechanism. Okay, and the it is because they're pretty much basic implementation. So anybody who gets hold of your client ID and client secret, your security is breached. Okay. So say I was working for XYZ bank and or XYZ company, and I was using some of the client ID and client secret for interacting with someone, some third party. Now, if I have the client ID and client secret, if I go out, I can start using it somewhere else, right? So that's where this client ID and client secret is a breach of your security in a generic way. And that's why it is not very secure. It is okay, and probably you can get, you will probably later in the stage, you will start to understand that actually maybe there are so many calls being made, but it is not real authenticated calls. So that's where you can start to use OAuth, which is the next set of security, next level of security, where you implement this in a way that let's take your question a bit back and try to understand why a OAuth is required. Okay, so it's basically when people were using password-based mechanism, right? When there was a web-based mechanism, when you would give or put your ID, your ID and password, and you will interact or get authenticated into your system. Now, OAuth came, OAuth 2.0. OAuth 1 was a pretty bad one, but OAuth 2.0 is where the system gets really secure. And what is happening is your identities are not really residing on your systems or the say APIM management system. Okay, your identities could be actually residing in your Azure AD or Okta or Ping identity or any other identity management solution where all your identities reside. However, when you want that those calls to be made, you want them to be authenticated. Okay, so when the calls are being made, the authentication will happen somewhere else, as in not in your API management systems, in say Azure AD. Azure AD will probably check your client ID and client secret or some other mechanism through which it will understand that you are authenticated. It will allow you or it will grant you some tokens. Based on that token, you will make the call. Now the call will come to the API management system. API management system will actually in maybe in the back end can go to the Azure AD to check that the token was actually issued by us already rather than being issued by someone else. Okay, so that's where this is an era where your identities can live anywhere and can be, say, Google. You can use your Google account. So you use already Google to keep your username and passwords. So you can use Google as an authenticator. Okay. Okay, and that's where you can implement this OAuth based mechanism to get your APIs to be secured.
Sure, thank you. So you said it's in that level. So is HTTPS more secure than OAuth 2.0? Or
Now,
it,
HTTPS you should always implement, period. Now, we are in an era where the security is a prime concern. HTTPS should always be implemented, be it in a browser systems or be it any kind of system. You should always implement HTTPS. MTLS or MATLS is where you have a next set of client and mutual authentication, where this is more secure or security on top of OAuth. You should implement OAuth, and then on top of that, you can implement mutual authentication to make it more secure.
okay, thank you.
Okay, cool. Okay, yeah. So that is about security. So how it works? Okay, yeah, pretty much. Open is it mostly nowadays works with Open API specifications or the swaggers, right? People should a set of or a group of companies got together and wanted to simplify this process of interaction with different machines or exposing with working with the APIs. Right, so we have Open API specifications. Currently, it is running with version 3.0, which defines the contracts of your APIs or the mechanism through which your API should be written. And it's a document which tells you the path or the APIs that are exposed, what is the response, what is the request, what are the data types that are in used, and allows you to pretty much figure out how to implement it. So this is a really good thing that has happened, and it has allowed to really standardize the API ecosystem. Using this, you can pretty much generate your client, you can generate your code, and you can be lean and thin, uh, pretty much. So this is how most of the new API management systems that you will see. You can use OPN API specifications to expose your APIs and show how exactly they work. You can, if there is a Open API specification, you can pull that up. You can set up your proxy immediately and then allow it to be working in just couple of minutes, and then you can apply these policies, which are standards and custom policies like rate limiting. When you create your APIs, you want your APIs to be not to overwhelm your backend system. Say your backend system can only handle 300 API calls or 3000 API calls a minute. So how will you handle that? There are standard policies like rate limiting and quota policies, with which you can stop the further API request beforehand rather than hitting your backend to and then failing it. Then you have caching policies, which allow you to instead of their hitting your backend, you can pretty much start sending response on your cached implementation and then return the responses, so that you can pretty much reuse whatever was pre-existing. I already talked about transform policies. So then there comes custom policies, and custom policies are like, say, you can some of the API management systems allow you to write some bit of code, uh, and that's where you will try to write. You can implement some of the code to do things that which are not possible in your uh, standard set of policies. Say you want to do a control flow. Okay, so if this then that, say if there is a header coming up with X, then hit a backend system or a static system. If there is a header come up with Y, go to this system, right? So those are the policies, custom policies, which you can apply and write or customize a bit, and then do things that your the standard policies don't allow you to. Okay, any questions? Nice. Okay, so now that we have covered basics of pretty much very basic of what the API management systems are, how they are built. Uh,
Apu, hi, sorry, quick question if you don't
sure.
mind. The caching, so where is this cache held? Is this part of the API management platform, or is it actually part of the API itself?
Yeah, so it is part of the platform. And in APG, there is a caching. It is a different kind of cache. Maybe it can be, you can. I mean, I don't know what they implement. It can be a Redis cache, or it can be anything.
Mhm.
Basically, these API management systems are actually the systems. I mean, monolith systems at some point of time. So because they've started to build on top of it, they have started to get into the containerized systems, and so maybe in near future, or maybe they're actually might be using Redis cache or something like that, right? So this is pretty much part of the platform.
Okay.
Okay. And in some terms, in Azure, API management is actually a VM-based solution till some time back. Now they are coming up with containerized
Mm.
gateways where you can have the gateway being deployed as a container.
Yeah.
Yeah. So Azure API management takes somewhere around 45 minutes or 35 minutes to get started,
Mm.
and that is kind of thing that you cannot really scale. So they are coming up with containers and things with which they can break that system and be agile again.
Mhm.
Okay,
Okay. Thank you.
cool. Okay, yeah. So yeah, now here we are in this magic quadrant for 2019, where you can see that APG is kind of the leader in the API market because they started pretty early. However, MuleSoft is catching fast and they're quite good also. You have Software AG and then IBM, which are the major leaders in this area. Then you have some of the niche players which are starting to get into this market and then coming up with that. Then we have Red Hat, Kong. Kong is open API, I guess, open source based implementation. And yeah, you will see that AWS is a bit lagging. It's not, they have a great microservices implementation by themselves, but however they are not, their API management is not that great at this point of time. So here we are, and this is a picture that you can see is coming up, and that's where we are getting into. And this market is pretty much booming, and we have, I mean, I guess now we have started to actually see the real use cases or the real requirements of API management systems. So nowadays, people are really using API management, and their market is going a bit higher side. Okay. Yep. So I will get into implementation patterns. I want to take a quick break for water. Guys, any questions? You can shoot. Okay, I'm back. I guess there was no questions. So yeah, let's come to the implementation patterns. Take an example of APG. However, and I have Azure also later on, but you can pretty much implement these patterns in any kind of API management systems, and you will see that they behave. They have started to come up or getting standardized. So this is the first pattern where your API management system lives in cloud, and in here APG, which is a platform PaaS solution, and where a client is makes a call via API gateway and your API management platform, and it comes and hits your Google Cloud Platform, which is running your microservices in multiple pods. So one is say account service, second is some say another mortgage service or some other microservice, and then you have your ingress handled by Cloud Armor. This is one pattern where the management is actually handled at the API pass layer, and you can get into your microservices and then pattern. There can be um, other components to it. However, in a bare minimum, this is how you can see it. And I will come to Azure, where I have more things in the picture, and that pattern can also be implemented. The next is where the micro gateways come into picture. Okay, the micro gateways are actually the lightweight components or lightweight gateways which implement some of the basic features of your full-blown enterprise gateway. Say they only come up with say some custom policies or some of the analytics and things. However, to use the full blown functionality, you will have to use the your real gateway. So in this pattern, this API gateway, a micro gateway, which is running inside your Kubernetes cluster, uses the configuration or syncs with the API gateway to get the configuration and handle the functionality. Say you can use your platform to handle or update the policies. The moment you make a change, the policy gets updated in your micro gateway, and the client can make the calls directly. In this pattern, what happened, the base, the benefit here is the hop from internet, or basically not the internet, I mean from a PaaS platform to your API gateway has reduced, and it can give you some performance improvements. Okay, and this is a second pattern. One of the areas the API gateways are used is in an external facing and an internal facing APIs. So external APIs are where you want your APIs to be used by your third parties. However, internal APIs are your APIs which are you don't want the others to discover and make use of. So you can use your API gateway to handle that scenario, and you can expose it. for internal or external purposes. So you have one pattern like that also, and I will talk in next slides. The third pattern you will see is where you can deploy your micro gateway into as a sidecar. Now, people who have already implemented microservices can see this and can easily understand. So, micro gateway becomes part of your pods, and you are running two containers inside a pod, and your client is making are coming directly via ingress, and first it hitting the micro gateway, and then your actual microservice gets it and responds back. So this is another pattern where you can see the real benefits of uh, implementing it in a container. However, this is a bit uncommon, but can be used in this way.
Why do you want Apu? Why do you want to use this pattern
This
compared to
is
the
why do I want this pattern is I mean I've seen this pattern suggested. However, I have not seen this really implemented. So I've seen this being suggested. I mean only in APG. In Azure, you will not find this. In
Hmm.
IBM product also, you will not find it. But I mean, just to show you, and actually, it can be. I mean, in going ahead, maybe I'll try to find a answer for this. That why exactly it can give, what benefits it can give.
Hmm.
But this is one of the patterns you can see. Okay, I'll probably try to dig into and give you the
Sure.
answer.
No problem. Thank you.
Yeah.
Yeah. Yeah.
Okay, so these are a few of the GCP or APG patterns that you can see, and I'll talk about Azure one. And this is a production grade setup where you can deploy this and what all is required. And pretty much similar pattern can be implemented in APG, where you have, I mean, I didn't spend too much of time creating the pictures. I pretty much use whatever was available. However, this pattern can also be implemented in APG and any kind of systems, right? So you will have actually host your API system on a DNS actual where you would implement or require your certificates, and with that you will allow your consumers to interact, right? Because you don't want your third parties to interact with Azure or some other name, right? You want your business name or business domain name to be exposed when the calls are being made. Okay, so you can implement DNS, expose your APIs or proxies on a DNS, and then you will implement some firewalls. In here you have a gateway, Azure API gateway, app gateway, which is listening to your API or interacting with your API management systems. In Azure, this is the pattern that is required. This whole thing runs inside a secured VNet, and it can be internal. You can make it as an internal VNet, or you can make it as external VNet when you don't want it to be exposed for outside. So then you use the keywords to get your certificates and apply your certificates in your sub gateway, and the calls are being forwarded to API management. API management then makes a call to your real microservice, and then the microservice might actually be interacting to your on-prem systems for your system of records. Maybe it has some data that is residing in your enterprise repository from where it wants to pull the data and respond back. So this is one of the patterns for implementation for a secured implementation. Another implementation I talked about was internal customers. So You don't want some of the APIs to be exposed. Right here, you have an external API and an internal API. You don't want this API to be exposed. So you can have policies in your API management systems, which or you can actually do it here on application gateway, where you want on a path-based mechanism, you want only the APIs to be exposed to the internal customers and rather than the external customers. So this is one of the patterns where you can segregate your APIs, external and internal, and then allow it to coexist in your single API management system. Okay, and this was pretty much I wanted to talk in terms of the architecture and every other thing. I wanted to do some hands-on. However, I found that the API management system I wanted to use is actually not working. So some there might be some updates that has been pushed by Azure, which is actually breaking my API management system. However, I will give you a quick look. So in Azure, if you go, you can create a API management system, and you can. It provides you four kind of what do you say? Four types of environments: developer, basic, standard, and premium, and a consumption type where you can. It is pretty much based on the calls. You will never use developer for your production systems. Uh, so you have pretty much standard and premium, which can be scaled as in the number of to handle the requests. And you can see you can have a 10 MB of cache in developer. In standard, you can have 1 GB of cache. There is a single region only, and you have multi-region support. And the premium one is where the calls can go up to 4,000 calls per second. Yep. So that's kind of API management system that you can create. Uh, and then this is a quick look on your API management system. So this is your management plane. Okay, and here you will see your things. You will see your proxies. So right now the service is dead, so I can't show you anything here, but you will see everything. Like I talked about analytics, I talked about gateways. So you can create or add more gateways to your system and they will appear here. So can't do this. I can give you a quick show of APG. So when you try to do it in APG, you will see here this is a platform-based solution. So you will reach here, and this is an area where they call it API proxies, and you can see some of the proxies that I've created. Uh, Say this is one of the API proxy that I created. This is how it is exposed. Uh, this is where you can see your APIs being in picture. Sorry, the proxy in picture, and you can add policies, and you can add more or do things here that you want to implement in your proxies. Okay, and you can create new flows and do other things here. So pretty basic. I guess you will find every in all kind of API management system. You will have this, and you can implement your proxy policies here. You'll see the revisions, and then you will see one cool thing with APG is you can actually trace your APIs. So basically about debugging your APIs, proxy APIs. When you are developing this is a very good feature when you can do a tracing or debug tracing your proxy policies, and then you can see how it works. You have publish area where you have products that I talked about. uh, Here you can create a product, and you will add proxies to it. So you can see multiple proxies that I've added, and they become part of a product. And then you have portal, as I talked about, developer portal. So you expose your proxies or show for discoverability. You create a developer portal where you can see here I've logged in, and I this is a custom, I mean, not a custom, you can customize the whole look and feel of this developer portal, and you can change it to what you need to give it as a theme and things. However, it basically gives you a set of features, like you can interact with your APIs, and you can explore them. Say this particular pet store APIs, what exactly it works. So we see that there are a set of paths that it exposes, and the responses, if it comes, what is the response. Okay, so you will get in response, these are the things that will come in the response. And when I make a request, say for this is a response that you get. Okay, so these are the few things that I wanted to talk about quickly, and pretty much I am yeah, kind of done for the day. And I guess we can take questions, and I can talk about anything else that you would want me to.
Okay, question. When I'm deploying my app, how do I register with the API management platform?
How do I
Register.
register
Yeah.
your
Is
app?
yeah.
Say
That's any service, anything. If I'm deploying something.
sure, sure.
So how does the registration process works?
Okay, yeah. So I'll take an example of this pet store, and you can find this. There is a Swagger pet store Swagger. So say I have a pet store microservice.
Mm-hmm.
Okay, Swagger. Sorry. So pet store is a service. This is being exposed by Smart Bear, and you will see this. There is a Swagger JSON. This Swagger is what gives me the power, I mean, thing with which I can expose my microservice. So ideally, what I should do is if I have a microservice, I should create a Swagger, and with that Swagger I can create a proxy in here. So we'll go to a API proxy, and I will say add a proxy here. Okay, so now here you can see there is a use OpenAPI spec. Okay, I can upload a file and I can import from a URL. Say I want to use this Swagger. Okay, so URL is this, and I want to say a pet store. Okay, so here it will auto detect what it needs to do, and it will create a proxy. Now you need to implement policies and flows and a backend system, which is your actual microservice, and then you are done.
Yeah.
So here are the common policies. I want API key. Impose quotas per app. Okay, I want to do this also. So I do this. Next is what are my virtual host where I will exposing it. So I can, for the time being, it is a evolution, but later on you want your own domains with to on which you want to expose, so you can use that. Okay, I'm using this. Okay, I can deploy it on the production. By the way, pretty much it comes APG and Azure. They all provide CI/CD solutions, so you don't need to really get into this doing by yourself. This is pretty much about playing, and this is where it will create this proxy and it will deploy it. Okay, and you can see I can in the portal I can see this. There is this Swagger Pet Store. It has automatically detected the target endpoint because it was part of this Swagger. So if you see this host petstore.swagger.io, this is the same petstore.swagger.io is being detected as a target endpoint or the microservice that it should try to get to talk to. Okay, if you reach here, you will say, okay, now you have the all the based on the Swagger, it has already detected that what all is required, and these are the policies that it has applied. Okay, so it will check the API key from the request, and only once it is verified that it will allow to do this. And you can make a call from your curl command or from your say postman
Yeah.
to hit the APIs and interact.
Yeah. Wonderful. Thank you.
Okay,
Yeah. Cheers.
cheers. Okay, guys, any other questions?
Hi, this might sound more stupid question, but just want to clarify on, I see that you're using epige.com, right? So if I want to have this kind of proxy set up on my own infrastructure, are there any libraries that would do this kind of management, or is it always I need to go through Epige
No,
and then forward to my own?
no. APG comes. So that's why I guess you might be didn't you were not here when I was talking about cloud. You can pretty much do it in your local on-prem systems. However, you a platform is what is already given to you, which you can utilize. But APG also can be deployed in your local on-prem system,
Right.
and you can use that.
Okay.
And Kong and some of the open source API management systems are there, which you can pretty much deploy, maintain, and manage yours in your on-prem systems. Even Azure nowadays has come up with on-prem gateways. However, in these scenarios, a few of the scenarios that I mean for Azure, it really has to talk to the management plane where it has to really interact with for the policies. It has to interact with let's see this one I was talking about, right? So a gateway which is actually deployed in your container or your on-prem. Say consider it is not a GCP platform. You are running your GKE via Anthos in your local system. However, you want to still use APG. You can deploy APG in your on-prem, and then it can talk to the API gateway or the management plane in cloud.
Okay. Okay. So we will just open up the
Yeah,
Epige Edge micro gateway to external
yeah.
Azure gateway, or in this case, the Epige
Yeah, but you
API
can pretty
platform.
much actually install the whole thing also in there is a I mean you can pretty much deploy APG completely in your on-prem.
Right. Okay. Okay. Yeah, I was just trying to see, from a network, from a security perspective, do we always have to interact with these external um,
Yeah, yeah.
service
You have
providers?
I mean you can deploy it internally also.
Okay. Okay.
Yeah, even all others are trying to do this for your local or hybrid systems. Yeah. Sorry, what exactly is Swagger? Okay. So yes, Swagger is basically your contract which defines that what you will be, what your APIs are. Okay. So here, if you, this is my Swagger or is a contract, right? Say what will be there. Okay. So I'm saying here that in this Swagger, I have these many endpoints or these many services or microservices that I want. So for say pet, I have a pet microservice which handles all these five calls. Then I have another microservice which is a store. Store microservice handle all three of the paths. And then I have a user microservice which is handled in my user resource. So via the Swagger JSON, I am telling that, okay, if you want to use, I mean, if you want to use this API, you can interact with it using these endpoints. So these are the URLs. Like, I mean, what I did here was I was interacting or making a request on API, say /o access token, right? So that's you can replace it with say a pet store and then get a response, and these are the ways you can show it. And your Swagger contains the definitions of your request response or any of the object that you see. Say this is pretty much used for standardization of your API calls, so that what you know what is the object you're talking to. Say a pet object is has these properties. A pet will have a ID, a category, name, photo, and tags and status. So things like that are defined and exposed in a Swagger.